So as we begin chapter 10 here, and we're starting at 10.2 with simplifying radicals, our essential question is, can I simplify radicals involving products and quotients? That means products, if we see that word product, we can think of, we're going to be multiplying. And if we think of the word quotient, we're going to be finding an answer to a division or dividing our problem. So let's talk about what a radical expression is. I gave two examples, 2 times the square root of 3 or the square root of x plus 3. These are expressions and they contain a radical sign. So we're going to have the radical symbol. Okay. There are a couple different ways that we can identify if something is simplified. And the first one is if the radicand, so inside our radical symbol, has no perfect square factors other than 1. So we're going to kind of talk about that. So if we have the square root of 3, that is simplified. There's no other perfect square inside of the number 3 except 1. We could have the square root of 10. That is simplified. Or we could have a number in front, 4 times the square root of 7. Those are simplified radicals. Something that would not be simplified would be the square root of 16, because we know what the square root of 16 is. The square root of 20 is not simplified. So we'll start to talk about those as well. So how do we simplify these? Let's go ahead and look at example 1. And the radical there is the square root of 160. So we got to find perfect squares inside of the square root of 160. I go down to finding what we call our prime factorization here. So if we think of what two numbers can multiply together to get 160, we know that we could take 10 and 16. I hope 16 jumps out at you as a perfect square. There are many times I tell students to go further with these if we're finding the prime factorization. And so 10, 2, and 5. 2 times 5 gets me 10. And 16 we know is 4 and 4 gets me 16. We could go further with 2 and 2 and 2 and 2. So if you were to multiply on your calculator, 2 times 5 times 2 times 2 times 2 times 2, I have them all circled there. That is the same thing as saying the square root of 160. Okay, so we have 5 2's and a 5. Put my multiplication sign between them. So those are equal in value. 2 times 2 times 2 times 2 times 2 times 5 is 160. So to simplify this, what we need to do is we need to pull out our perfect squares. Well, we know 2 times 2 is a perfect square. It's 4. And when we take the square root, we get 2. And here's another perfect square. 2 times 2 is 4, so that's a perfect square. And when we take the square root, we get 2. So to simplify the square root of 160, your simplified form, look at what's in front. We have 2 times 2, which is 4. Square root, what's left on the inside the radical symbol is 2 times 5, which is just 10. So this is simplest form. What you're going to notice is with simplest form, we are not going to change it to a decimal. We're going to leave it in a radical form, radical sign. Let's go ahead and look at our next example. Here we have letters. That's okay. Okay. We're taking the square root of 54 n to the 7th. So let's go ahead and let's think about what can we divide 54 by. And we know it's 6 and 9. We know this would be 3 and 3 and 2 and 3. So what this means is if you were to take 2 times 3 times 3 times 3, you would get 54. So let's write it out. 2 times 3 times 3 times 3, and then 1, 2, 3, 4, 5, 6, 7 ends. I tried to fit them all there. I was running out of space. So we got to find our perfect squares. Well, 3 times 3 is 9. It's a perfect square. So I have a 3 that I can pull out. The square root of 9 is 3. I can't do anything with my 2. I'm going to leave it. I can't do anything with my 3. Well, what do you know about n times n? Well, that's n squared. When you take the square root, we have an n that comes out. And we have another grouping of n squared. So we have another n that comes out. And we have another grouping of n squared. So we have another n that comes out. So we end up with 3n to the third outside of my radical symbol. And what we couldn't do anything with was 2 times 3 times n, which is just 6n. So we're going to simplify with letters the exact same way. We're looking for perfect squares, and we take the square root, and that then comes out of the radical sign. So let's talk about when we multiply. When we multiply, we have to have the same index. Okay, the index is the number that's written right here, and I know that there's nothing written, and so it means square root. So the indexes are the same here. So in order to multiply, we literally can just multiply it together. Let's go ahead and look at the front. I'm going to start with my 2 times my 3, and I'm going to get a 6. And then inside the radical symbol, I have 7 times t times 14 times t squared. It all can be multiplied together. If I write it in prime factorization form, we would have 7t 2 times 7 times t times t. So that is writing it in prime factorization form. So I see I have a 7 and a 7. Well, 7 times 7 is 49. 49 is a perfect square. So we can bring a 7 out front. And we have t times t, or t squared, so we can bring a t out front. And otherwise, all I have left on the inside is 2 and t. So 7 times 6 out front, that's going to be 42 t. And inside the radical symbol, we still have 2 t. So when we're multiplying, you can just think about multiplying everything together as long as they have the same index. So let's look at the next one. 7 times 3, that's going to be 21. And then we have 5x. Let's look at 20. 20 we know we can write as 2 times 2 times 5. And then we can have 5x's. So 2 times 2 is 4, 4 times 5 is 20. So all I did was write this out. I have my 7 times 3, which is the 21, and I wrote it all out. Let's group these. 2 times 2, that's a perfect square. 2 x's, so there's an x that comes out. Another set of 2 x's, there's another x. Here's a third set of 2 x's. And my 5's even come out. Everything. This is going to be completely simplified. So what we're going to look at here is 21 times 2 times 5. And we get 210 x cubed. It is a perfect square. Everything comes out of the radical symbol. Let's go to problems here in which we're going to look at dividing. And when we look at dividing, let's just ask ourselves, 64 and 49, are those perfect squares? Because it's saying the square root of that. Well, the square root of 64 is 8. The square root of 49 is 7. Because they're perfect squares, it's just 8 divided by 7. You have simplified it. Now on the next one, let's see if we can simplify the fraction inside the radical symbol first before we simplify. So if you think about this, I want you to think about, can we divide 8 or 50 by a value, any value. 8 and 50 we can both divide by 2. So if I divide the top of my fraction by 2 and the bottom of my fraction by 2, I end up with 4x cubed divided by 25x. Now let's take a look at our x's. If I have 3 x's on the top and 1 on the bottom, we could write it out. This is what it's going to look like. We know anything divided by itself is 1, so this cancels. So we really have 4 in the numerator, x squared divided by 25. So we're starting to simplify here. Now let's take a look and talk about, are these perfect squares? 4x squared, 4 is a perfect square. You get 2, x squared, take the square root, you get x, and divide by the square root of 25 is 5. This would be your final answer, 2x divided by 5. Now, some of our topics that we normally would cover we're not, because we've lost so much time with the pandemic. But if there is time, I'm sure your teacher will talk about what we call rationalizing the denominator. That's all I have for today. Have a good night.